Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you're all doing well. Welcome to another video from our channel Easy Chemistry for All. This is Mr. Muad and I hope that you are benefiting from these videos so far. Please don't hesitate to contact me or leave a question or comment in the comment section below the video. Thank you for helping us reach 284 subscribers so far. To be honest, the number is a little bit low to what I expected, but nevertheless, thank you for your efforts to share the channel with your friends. And please, if you did not subscribe yet, please subscribe. It's just one button, and that will help grow the channel so that people can find it when they search on YouTube, and they can hopefully benefit from these videos, guys. So thank you very much for all your help. So we are going to start with Module 5, Lesson 3, which talks about periodic trends. Okay, so we'll learn about periodic trends and how they change in the periodic table. Okay, and these are our learning objectives for part 1, guys. So we are going to learn and explain the trends in atomic and ionic radii across the periodic table. So radii is the plural of radius, اللي هي نصف القطر. So atomic radii, نصف قطر الذرة. Describe the octet rule and explain the formation of ions. So this is what we want to understand from part 1, guys, okay? And we'll see it while we are going. So let's start with a quick revision of some keywords. So atomic radius, اللي هو نصف قطر الذرة. So the word radius, guys, is singular, مفرد. The word radii is plural, okay? So what do we mean by atomic radius? It's the distance between the nucleus and the outer energy level. Remember the energy levels in Bohr's model, n equals 1, 2, 3. So if I have an electron here, then this distance, okay, we call it a radius or atomic radius because this is the electron in the highest energy level, okay? Same thing for ions, okay? So what do we mean by a trend? A trend is a general direction to which something changes, okay? So we'll see how these change, okay? These trends. So periodic trends are specific patterns in the properties of chemical elements that are revealed in the periodic table of elements. So these are properties, خصائص تتغير بتغير موقع العنصر في الجدول الدوري وفيها trend يعني تتغير في اتجاهات معينة, okay? So from the left to the right, from up to down in the periodic table, okay? Now, you should understand that atomic size or atomic radius يعني حجم الذرة أو نصف قطر الذرة is a periodic trend that changes by electron configuration. And of course, you know that different elements have different electron configurations, right? So now, if we look at metallic atoms or metallic bonds, for example, this is a sodium atom, okay? You can see that the radius of a metal atom is 1/2 the distance between two adjacent atoms in the crystal. So if you have two atoms, right, then the distance from the nucleus of the two atoms, so if this distance, we call it d, then the atomic radius is equal to d over 2. It's the half. This is when we are talking about metal atoms, لما نتكلم عن الذرات المعدنية أو الفلزات, okay? Now, if we are talking about nonmetals, and we'll talk about this in Module 7, mainly Module 7, when we talk about covalent bonds. So the radius of a nonmetal atom is often determined from a molecule of two identical atoms. Okay, so it's actually the radius is the overlap, is the distance from the nucleus, دائما المسافة من النواة to the overlap or the border where the atoms overlap, okay? And we'll see this later in Module 7. So you should remember the difference between both. Okay? Now, guys, this is the electron configuration of sodium. Can you tell me what is the group, the period, and the block? So, of course, from what we learned in Lesson 2, the highest energy level is 3, so it's in period 3, block S, and group 1. What about potassium? What do you think where will its location be in the periodic table? So again, last energy level, so it's going to be period 4, block S, and group 1, right? So they are in the same group. But which one will have a bigger size or a bigger atomic radius? So will sodium have a bigger atomic radius or potassium? Okay, how can we know? So this is a trend. We'll see how atomic radius changes in the periodic table, okay, or the size of atoms. So this is just for you to remember the periodic table of elements. Okay, so how does the atomic radius change in a period and through a group, and why? Okay, so if we look at group 16 or group 15 or group 14, let's focus on group 16. From up to down, these are elements, right? Or for example, group 1, see sodium, and this is potassium, okay? So let's talk about group 16. If we analyze it, what happens to the atomic radius when we go from up to down? As you can see, the size is increasing, right? Now, what's the reason for that, guys? Because when we increase the period number, the energy levels increase. So for example, if we are in period 1 and group 1, this atom has only one energy level. If we go down at period 2, this atom has 2 energy levels, so bigger size. If we go to period 3, this atom has 3 energy levels. If we go to period 4, this atom has 4 energy levels, and so on, 5 energy levels, 6 energy levels. So that's why when we go from up to down, the size will increase, because we are adding more energy levels, more shells to the atom. Okay, guys? Easy? Okay, now let's see what will happen across a period. يعني من اليسار إلى اليمين, in a period, in a row. Okay? So look, what happens to the size, guys? In period 5, for example. The size decreases, right? As you can see. Now, what is the reason for that? So, the atomic number increases when we go from the left to the right. عدد البروتونات يزداد من اليسار إلى اليمين. So the nucleus will have a more positive charge. And you know what happens between positive and negative charge, right? Attraction, تجاذب. So the electrons or the protons in the nucleus will pull the electrons, and then that will reduce the atomic size. What do I mean by that? Imagine you have 2 atoms in period 2. Let's talk about lithium and beryllium. Okay, lithium has an atomic number of 3, and beryllium an atomic number of 4. العدد الذري. So here you have a charge, okay, and so this is lithium, 3 protons, okay, and you have 2 electrons here and 1 electron in energy level number 2. So this is the valence electron, right? And now let's draw beryllium, okay. So beryllium has 2 electrons here and 2 electrons in the outer energy level number 2. So it has 4 protons. Okay, guys? Alright. So guys, this one has 4 protons. Okay, so the positive charge here is stronger. And you know that the electrons here are actually negative. So which one is going to pull electrons in a stronger way? مين اللي بتجذب الإلكترونات عندها بطريقة أقوى؟ النواة اللي عندها 3 بروتونات, the nucleus that has 3 protons, أو the nucleus that has 4 protons. So of course, because you have 4 protons here, the positive charge is bigger here, okay? So write it as big positive. So actually this one becomes like this. Do you see? The distance will be reduced. هاي المسافة بتصغر. So you will still have, sorry, I draw it in a bad way. Excuse me. You will have a positive charge here. Okay, this is the first energy level, and now this is the second energy level. You will have 2 electrons, and here 2 electrons, and this is beryllium. So الإلكترونات راح تقرب للنواة. The electrons will be closer to the nucleus. And this is what we talked about it here. When the atomic number increases, protons increase, the positive charge is going to increase, and it pulls. تسحب الإلكترونات عندها بطريقة أقوى. So the electrons will be pulled in a stronger way. Okay, in a stronger way, and hence reduces the atomic size. That's why, this is the reason why the atomic size decreases from left to right. Okay, so here's a summary, okay, about the atomic radii, trends in the atomic radius. So generally, if you go from left to the right, the size will decrease, and when you go from up to down, the size will increase. This is what you need to remember for the questions, guys, and you need to remember these reasons why. Okay. Okay, now let's go and check our understanding. Choose the correct order of increasing atomic size. So do you see these 4 atoms? I want you to order them من الأصغر إلى الأكبر بالنسبة للحجم, from the smallest to the biggest. Okay, you can stop the video, try, and then come back. Alright, so if you have something like this, guys, okay, you can just try and remember what happens from left to right. So the size will decrease, and up to down the size will increase. So automatically you can, in period 4, you can know that K is stronger or bigger than Ca, and it's bigger than Na. You know this, right? You already know this, that K is bigger than Ca is bigger than scandium or Sc, because when we go from left to right, the size will decrease. Now we have sorry guys, not Na, K. I'm talking about K here. Okay. Now what about Na? الحين, if you think about Na, it has how many energy levels? 3. So 1, 2, 3. What about here? How many energy levels are there, guys? All of these have 4 energy levels. كل العناصر هنا عندها 4 energy levels. So all of them are bigger than Na because they are below. Because they have 4 energy levels, right? Because they are in period 4. So that makes us choose answer number 2, where Na, okay, I made a mistake here. K is smaller than Ca, is smaller than scandium, guys. I don't know why I put K or Na there. And then now we can put Na here. So this is the order, guys. Okay, K is bigger than Ca, bigger than scandium, and Na is smaller than all of them because it's up and has only 3 energy levels. All right. Okay, guys, let's go and discuss the octet rule. Okay, I want you to look here at group 18. If you remember, this is group 18, guys, right? Noble gases, الغازات النبيلة. Now look at the electron notation for all of them, except this one. Don't look at helium. Look at all of them. You will notice there is something common. Here we have 8 valence electrons. 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 طبعا اللي مش متذكر الفالنس electrons, for those of you who don't remember valence electrons are the electrons at the highest energy level. So the highest energy level here is 4. We have 2 and 6, so 8. Here is 5, 2 and 6, 8. Here is 6, so we have 2 and 6. It's 8 valence electrons. All of them have 8 valence electrons, right? In their s and p orbitals. So when you have 8 valence electrons, actually you are stable. You are happy. Because atoms have one goal in life, and that's to be happy. How can they be happy? By having 8 valence electrons. Okay? So if you have 8 valence electrons, it means you follow the octet rule. So octet from octopus, and octopus has 8 legs, right? So here we mean 8 valence electrons. Okay? So except for helium. If you have only S and you have S2 full S, okay, then you are also happy. هذا الexception الوحيد في هذا الجروب. Okay? So atoms lose or get electrons to have 8 valence electrons. Okay, so atoms lose or get electrons so that they have 8 valence electrons, guys. Okay, and they can become happy like the noble gases of group 18. Alright, why are we explaining that? Because we are talking about ions. Okay, نتكلم على الأيونات، الأيون الموجب والأيون السالب, which we are going to talk more about in module 6. But now we are actually trying to differentiate between an atom size, atomic radius, and ionic radius. Okay, in the periodic table. So look here, guys. You have a sodium atom here, Na. The atomic number of Na is 11. Has 11 protons. 11 protons. Now it's going to lose an electron. بتفقد electron سالب. So when it loses an electron, it becomes a positive ion. تصير أيون موجب. What's the atomic number here? Number of protons? It's going to be 11, guys. Why? لأنه أنا قلت لك فقدت electron, ما قلت فقدت proton. I said it loses an electron, not a proton. So if we look at the electron notation here, this electron we are going to remove. So what's the new electron notation? 1s2, 2s2, 2p6. How many valence electrons are here now? 8. So now sodium is happy in the octet rule, remember? Because now it has the same electron notation as Ne. So it's happy, okay? Now what I care about here is not this, I care about the size. So it lost an energy level, isn't that right? So here it had 3 energy levels. In here it has only 2 energy levels, right? So what happened to the size? The size decreased, okay? Now let's look at chlorine atom. Chlorine has 17 protons, the atomic number. It gains an electron, gains 1 electron, okay? Still, it has 7 protons because I'm talking about electrons, guys. So when it gains an electron, الإلكترون شحنته سالبة. إذا اكتسبت إلكترون بتصير أيون سالب. It's going to become a negative ion, okay? And we are going to add an electron to the p here because it's 5, so it will become 1s2, 2s2, 2p6, 3s2, 3p6. Again, 8 valence electrons, happy. But now when you get an electron, what happens to the size? The size will increase. The radius increases, okay? So when an atom becomes a positive ion, the radius decreases. And when an atom becomes a negative ion, the radius increases, guys. So you need to remember this, okay? And this is what we talked about in here. Now the question is why? Why does this happen? So when atoms lose electrons and form positively charged ions, they become smaller for 2 reasons. Reason number 1, the loss of a valence electron can leave an empty outer orbital or outer shell. Remember, sodium had 3 energy levels. You have an electron here. So if you lose an electron, now you have only 2 energy levels. That's what number 1 is talking about. That's why the size is going to decrease. Now, number 2, electrostatic repulsion decreases, allowing the electrons to be pulled closer to the nucleus. Okay? So, what happens is that when you remove electrons from the outer energy levels, الإلكترونات ما بينها في تنافر. There is a repulsion between electrons. So if you remove an electron, the amount of attraction now between the positive charge and the other nucleus increases. So it pulls the electrons towards it in a stronger way, and that's why the size will decrease. Now, when atoms gain electrons, they can become larger. Why? Because the addition of an electron increases electrostatic repulsion. What does that mean? Imagine you have an energy level here and you have 2 electrons here. They are far apart, right? Imagine you gain an electron. So you have 1 electron here, 1 electron here, and 1 electron here. Now look, صار في تنافر ما بين هاي وهاي وهاي وهاي، صح؟ So الذرات لما تتنافر، الإلكترونات لما تتنافر تتباعد. So that will become like this. Why will it become like this? so that it will increase the distance between the electrons. يعني راح يتنافروا ويتباعدوا عن بعض. That's why the radius increases. Okay, so the word repulsion is تنافر، وهذا هو السبب اللي يخلي الذرة أو الأيون يزداد حجمه لما يكتسب إلكترون. Okay, now what we care about is when we look at the periodic table and see how these sizes change. Okay, so the ionic radii of positive ions decrease from left to right and increase from up to down, same as atomic radius. Okay, but the ionic radii of negative ions generally decrease from left to right, beginning with group 15 or 16. شو معنى هالكلام؟ معنى هالكلام إنه ال positive ions they will generally decrease but stopping at group 14 or 13. Now starting from group 15 or 16, the negative ions size will start to decrease. But negative ions in the same period are bigger than the positive ions. So look here, for example, we are looking at period 2 here. Look at period 2 guys. البوزيتيف ions شو يحصل لهم؟ قاعدين ينقصوا صح؟ إلى أن نتوقف عند جروب 14. لما نتوقف عند جروب 14 خلاص أنا ما قاعد أكون أيونات موجبة، أنا قاعد يكون عندي أيونات سالبة. طبعا هذا بنتكلم عليه في الموديول الجاي، ليش هاي الجهة عندها أيونات موجبة وهاي الجهة عندها أيونات سالبة. But I'm just trying to make you remember that the negative ions will have a bigger size than the positive ions. But when you go from left to right here, the negative ions size will also decrease. So just try to remember that guys, okay? Alright. Now let's go to a question. Try to answer this question based on what we saw in the previous slide. And you can go back and repeat it, okay? So try to answer this question and come back to the video. Okay guys, so how can we know which of these ions will have the largest ionic radius? Okay, so this is not an easy question. You might think that Mg will have the biggest, right? But we are talking about ionic, not atomic radius. So if we look at Mg, okay, Mg plus 2, so the electron notation for Mg is actually 1s2, 2s2, 2p6, 3s2, right? 12 electrons. Now Mg plus 2, what does that mean? It means it lost 2 electrons. So Mg plus 2 is 1s2, 2s2, 2p6. Okay guys? Al positive 3, this is the electron notation for Al, okay? 2p6, 3s2, 3p1. Do you see these 3 electrons? They are removed. عشان شي الشحنة بالpositive 3. That's why the charge is positive 3. So the electron notation is 1s2, 2s2, 2p6. Now oxygen and fluorine, so oxygen and fluorine, they have these electron notations. 1s2, 2s2, 2p6. And this one 1s2, 2s2, 2p6. So all of them have the same electron notation. What do we mean by that? All of them have 2 energy levels. So 2 energy levels. Okay. So how can we know which one will have more or bigger size or not? So automatically, because these are in the same or have the same energy levels, احنا دائما قلنا انه الايونات السالبة عندها حجم اكبر من الايونات الموجبة. So the negative ions have a bigger size than the positive ions. So automatically we remove the positive ions. Now, remember what happens to the size when we go from the left to right? The size will decrease, right? So oxygen should have the biggest or the largest ionic radius, guys. Okay? I hope you understood this part. Okay? So this question tells you which element below could be expected to have positive ions with the largest ionic radii. So guys, you know that this part will be negative ions, right? Negative ions. Where did we see that? So it's here. So negative ions, and here are positive ions, right? So automatically F and Rn are out. Now, which one do you think will have bigger ionic radius, Mg or Cs? The one with 2 energy levels or the one with 5 energy levels? So why did I say 5 here? Because it will lose an electron and will remove 1 energy level. And this one will lose an electron and will remove 1 energy level. That's why it's not 3. So of course it's going to be cesium because it's down here. It has bigger size, okay? So guys, that's the end of part 1. We are going to continue inshallah with part 2 in the next video, okay? So we'll continue with part 2 in the next video, right?